What do you think is the largest source of electricity around the world? Turns out that burning coal contributes to 35% of our electricity needs. A distant second is natural gas at 22%. Basically, burning coal and natural gas contributes to 57% of our electricity needs. Now, if you want to imagine that, imagine you have a bulb or a fan running for 10 hours. Okay. And 6 of those hours were powered by burning coal or natural gas. That's a lot, isn't it? Now, what is the problem with depending on coal and natural gas? Well, burning these things causes a lot of pollution. And that's really not good for the environment, right? Okay. The other issue is that both of these are non renewable sources of energy. What does that mean? That means these will get over pretty soon. How soon? Well, as of now, we still have some time. We have a few hundred years left. But considering the fact that our electricity needs are increasing, our energy needs are increasing, we can never say this may get over a little quicker than what we thought it would last. Right? And so, what we've been looking for the past 100 years is alternate sources of energy. And one of the promising alternate sources of energy has been nuclear energy. Let me show you something interesting about nuclear energy. Let's say I have 1 ton of coal. The amount of energy that 1 ton of coal can produce is equal to the amount of energy that a tiny piece of uranium can produce. Yes. Now, this may kind of make you think that uranium is always the better option, right? But it's not as simple as that. Let's stack them up together and compare them for a few factors. So, when it comes to less pollution, uranium is the no brainer, right? Because uranium is not burnt and it doesn't produce any harmful smoke or gases, whereas coal needs to be burnt and that burning produces a lot of harmful gases. When it comes to compactness of the fuel, uranium is compact, whereas coal is bulky. But when it comes to the cost of production of 1 unit of energy, coal is the winner here. Why? Coal is way, way, way cheaper and it takes much less amount of money to set up a coal power plant as compared to a nuclear power plant. And so coal costs less to produce the same amount of energy. Now to the last point, risk. Both of these sources of energy have their own risk factors. But coal, in some ways, when it comes to the production of energy part, coal is a lower risk option. Let me explain why. Well, you see this picture of this person holding this piece of uranium in their hand? This is not a real picture. This is an AI generated picture. Okay, it would be stupidity to hold uranium in your hand. Why is that? Well, uranium produces radiations that are harmful for us. Wait a minute, let me take a step back and explain what radiation actually is. Radiation is, you can think of it like an X ray. Okay, so it's like an X ray where certain rays are being produced, but these rays are not really visible. Okay, the only difference between an X-ray's radiation and the radiation from a uranium block or radioactive waste from nuclear reactors is that the radiation from nuclear reactors is a billion times more energetic, and so it can cause a lot of damage to tissues. Even X-rays, by the way, cause damage. If you went through, say, 100 X-rays, you could have some amount of your muscles or tissues being damaged, right? Whereas if you experienced radiation from, say, a nuclear power plant, even a minute or two or even 10 minutes of exposure can cause death. In fact, even less than 10 minutes can cause death. And it's not just death, radiation exposure can cause mutations in genes, which can cause future generations to be born with birth defects. It can cause a host of other diseases like cancer. It's something you don't want, right? And so, because radiation is so harmful, we got to be a little careful when we construct nuclear reactors. Now, in general, nuclear reactors work fine, life goes on. But sometimes we have problems. And let me give you a few examples in history when we've had problems. So in Fukushima, this is in Japan, this is the name of a place, there was an earthquake in 2011. And there was a nuclear reactor in Fukushima. And this was what happened to the Fukushima reactor. The earthquake and the tsunami that was generated by the earthquake caused a lot of damage to the Fukushima reactor. Similarly, back in the 80s, in a place called Chernobyl, this was in 1986, there was a technical failure at the Chernobyl nuclear reactor. And this is a picture of the Chernobyl nuclear reactor a few days after the technical failure. Imagine, even a few days after the technical failure, smoke continued to rise from the reactor. It was that bad. So, a small technical failure, or an earthquake, or a flood, or a tsunami, things like these can cause issues in nuclear reactors and expose people to radiations. And that's why we've got to be careful. And obviously, we don't run a nuclear reactor without taking precautions. So I'll run you through some of those precautions that we take. So this is a picture of the nuclear reactor. This portion specifically is the reactor. And within this reactor is the uranium, which is our fuel. This is actually the uranium. Now, what happens is if there's a technical failure or if there's some kind of explosion that may happen, we have something called an emergency cooling system, which can immediately pour in water and cool the system down in the fraction of a second. And usually we use cold water or other coolants for this purpose. The next system we have in place is called a containment building. Outside all of this, we have a large concrete structure that protects this entire nuclear reactor so that even if there is some accident, explosion, or leak of radiation within the reactor, the containment building will keep all this radiation inside, will contain the radiation inside. And this is how the containment building looks from the outside. We also have certain sensors which are very sensitive to any minor changes in the nuclear reaction. Even if there's a tiny change in the temperature or a tiny change in the rate of the reaction, these sensors immediately go off and they stop the entire nuclear reaction within a fraction of a second. All these systems work together to ensure that our nuclear reactors are safe and we can continue to produce electricity from them. That's it for this video. Thanks for watching.